The universe was a busy place 11 to 12 billion years ago, or just 2 to 3 billion years after the Big Bang. That is the period astronomers refer to as the cosmic noon, when young galaxies were forming stars at a fast and furious rate. High noon for the cosmos has long since passed, or it would seem to have. But there is one pocket in which it persists. And, in another in a growing series of triumphs, the James Webb Space Telescope has returned an eye-popping image of that small region, revealing new secrets about the origins of the universe. The object featured in the just-released picture is known as NGC 346, a portion of the Small Magellanic Cloud, SMC, a dwarf galaxy located just 200,000 light-years from Earth. NGC 346 was already known as a nursery for infant stars, as are many parts of the modern universe. Those areas form stars more slowly than during the cosmic noon, because they are known to be low in metals and other elements heavier than hydrogen and helium. Those heavier elements make up space dust, which contributes to the formation of stars, due to their low metal content. However, modern star-forming regions are thought to be relatively dust-free. That doesn't stop them from creating stars, just not at the pace they were formed during the cosmic noon. The Webb's observations of NGC 346, however, revealed just the opposite of what was expected: great clouds of dust that accelerate the formation of stars. A galaxy during cosmic noon wouldn't have one NGC 346 like the Small Magellanic Cloud does, it would have thousands, said Margaret Meixner, a principal investigator in the study that produced the new image, in a NASA statement. But even if NGC 346 is now the one and only massive cluster furiously forming stars in its galaxy, it offers us a great opportunity to probe conditions that were in place at cosmic noon. The presence of so much dust in NGC 346 confirms the pre-existing theory that galaxies during the cosmic noon were also heavy in dust, offering, effectively, a close-up artifact of the ancient universe. It also suggests that NGC 346 might not only be forming stars, but planets too, which accrete from swirls of metallic dust. If that's so, it means Earth-like planets may have formed during the cosmic noon as well, much earlier in the history of the universe than planetologists had originally believed. Since the Small Magellanic Cloud has a similar environment to galaxies during cosmic noon, said astronomer Guido De Marchi, a co-investigator for the study, in the NASA statement, it's possible that rocky planets could have formed earlier in the universe than we have thought. The image itself tells part of that star and planet formation story. The various ridges of pink and orange material represent clouds of dust being broken down by young stars beginning to accrete and exert their gravitational muscle. The pink clouds represent energized or superheated hydrogen, which sizzles at temperatures of 10,000 degrees C, 18,000 degrees F. The orange regions represent colder, molecular hydrogen made up of two hydrogen atoms, which has much lower temperatures of -200 degrees C, -300 degrees F. It is the colder hydrogen that joins with the primordial dust to form the young stars. Whatever the chemistry and stellar physics at play, it is undeniable that the new Webb image is yet another dazzler from a machine that has been in space for just over a year now and has done every little thing its designers and mission planners have asked of it. The new picture is just the latest in the album of cosmic landscapes the telescope has beamed home. In the 20 years of life the Webb has ahead of it, that science-rich image will not remotely be the last.